afternoon, everybody. Welcome to Pwning your Java messaging with deserialization vulnerabilities in Mandalay BCD with Matthias Kaiser. Before we get started, I have a few brief announcements. You are invited to stop by the business hall located in Bayside AB during the day and for the welcome reception from 1730 to 1900 tonight. Black Hat Arsenal is on in the Palm Foyer on level 3. And join us for the Pwning Awards in this room, Mandalay Bay BCD at 1830. Please put your phone on vibrate now. It makes it much easier for the rest of us to ignore the ringing while you wait for it to go to voicemail. And at the end of the presentation, there will be time for questions. Please come up to one of the microphones in the aisles to ask your question so that we can capture it for the video. Thank you very much. Matthias Kaiser.
Thanks a lot. Thanks. I also would like to welcome you to my talk, Pwning your Java messaging with deserialization vulnerabilities. Before we start, I would like to take the chance to introduce myself a little bit more. I'm Matthias Kaiser. I'm currently the head of vulnerability research at Code White in Ulm. We are a small security startup. We are doing a lot of red team pen testing, long-term engagements with our blue chip customers. And we are based in Ulm, which is between Munich and Stuttgart. So whenever you want to go to the Oktoberfest, just let us know and come by. I used to work as a software architect in the past and also software developer, mainly in the Java world, for a company called Airbus, or Airbus Military. And since 7 years, I'm enjoying the technical security stuff and offensive security. Since of my past, somehow specialized in Java security. I found a lot of bugs in enterprise products of Oracle, IBM, VMware, SAP, Red Hat, and so on. But most of them are server-side or locals. But recently, I'm looking more into the Windows world and also client-side stuff. So it's a different field. If you're interested in Java deserialization at all, follow me on Twitter. My nick is Matthias_Kaiser. Sometimes I drop some 0 days, but not that often. So, and now it's time to show you the agenda for today. So I will start with a short motivation why I did this research and why I'm presenting this here. Then I want to give you a short introduction what the Java object serialization protocol is. Then we'll go into what the Java message service is. The most interesting part will be how we can attack the Java message service. I also will introduce to you a tool which is called JMAT. And since I'm not a big fan of showing tools on slides, I also have a demo for you, a real live demo. And we will end the session with a conclusion, also with questions and answers. Okay, so let's get started. The motivation behind this research is that I spent about, let's say, 1 year into looking into server-side products, especially for Java deserialization vulnerabilities. And as from the time when I was an architect, I already knew, okay, there are a lot of core technologies in the Java world which make heavy use of Java's object serialization. For example, the ancient remote method invocation, RMI, it's using serialization very heavily, and on top of the RMI, you can find JMX, which is the Java management extension. It's using RMI. And there's another core technology, which is the Java message service, which is also using Java serialization. I haven't found that many research in the past. So there was very good research from Gursev Singh Kalra of McAfee Foundstown in 2014, a pen tester's guide to hacking active and queue-based applications, or JMS applications. He also released a tool which is called JMS Digger. Just as a side note, whenever you're already using this tool, you might think about to update some libraries after my talk. There's another very good presentation from Georgi Geshev of MWR InfoSecurity. Your queue is my queue. It's more about the overall security posture of queuing products, and I can only recommend to look at that. I haven't found any research regarding how you can attack JMS-based applications using deserialization, and that's the reason why I'm here, and also to present it. So I have some disclaimers for you. First of all, this talk continues on my research on Java deserialization vulnerabilities. I have already given 2 talks about this topic in several at other conferences, so I won't cover all the technical details about how you can find Java deserialization vulnerabilities and how you can exploit them using gadgets. I just will give you a short introduction to the topic. If you're more interested in that topic, there are very good presentations. First of all, we have one from Chris Frohoff, one of the key person in the whole Java deserialization thing. He presented the presentation at OWASP San Diego 2016, so this year it's Deserialize My Shorts. There's another one from Alvaro Munoz and Christian Schneider. They presented an RSA serial killer, great presentation. And as I said, I have already given 2 presentations, one at Infiltrate and another one at the German conference, which is called RUSEC, about Java deserialization overall. Okay, so let's look at the short introduction on Java's object serialization. So first of all, I just want to clarify the word serialization, deserialization. So whenever I'm talking about this, I mean, whenever you have an object in the JVM and you want to represent it as a stream of bytes using a specific protocol, which is the object serialization protocol, I'm talking about serialization. And then you can take the bytes and store it, for example, in a file or in a database or send it over network. And later on, if you deserialize it, you just take the stream of bytes and reconstruct the same object again using the object serialization protocol. That's serialization and deserialization for me. And just to give you a short summary what the big problem with Java's serialization is. First of all, Java provides a serialization API. So every class which wants to get serialized and deserialized needs to implement the Java I/O serializable interface. It's a tagging interface. It doesn't define any method. It's just for tagging. And whenever you want to write a serialized object or serialize an object, then you invoke the method writeObject on the object input stream, object output stream class, and the bytes will go into an output stream. Whenever you want to read a serialized object, you use any of those hundreds input streams as the source for a object input stream .readObject call. And readObject will just return a serializable object, which is read from the input stream and reconstructed using Java's object serialization protocol. The serialization protocol is a binary protocol. If you're interested more, you can go to the Oracle webpage. There's a very nice specification there and also a grammar. For example, if you want to implement a parser for that, you can use the grammar from there. A deserialization vulnerability happens when we are taking untrusted input and use it as an input for a object input stream .readObject call. So whenever we take bytes from untrusted and deserialize it, that's a deserialization vulnerability, not more, not less. For exploiting deserialization vulnerabilities, we need to use existing classes which are in the class path of the target application. And we need to find serializable classes that allow us, for example, to abuse them and to trigger something like writing files, dynamic method calls, or loading libraries or stuff like that during the process of deserialization. Such classes exist. All the researchers call them gadgets, and currently we have about 15 gadgets in very common libraries and also even in the Java runtime environment. Exploiting deserialization vulnerabilities can sometimes be as easy as this. We have a HTTP post request here, and we're just sending the post request to the target server, which is, by the way, Oracle Hyperion, API product of Oracle. And we just use a commons collection gadget here, and you might see it, there's a calc.exe in there. And whenever this gets serialized on the server side, calc.exe pops up. In order to make the exploitation of deserialization vulnerabilities easy, Chris Frohoff created a great tool which is called YSOSerial. You might already know that. It's open source, it's hosted on GitHub. It serves as a public repository for all known gadgets. And currently, we have about, or Chris has about 15 gadgets, for example, for the famous Apache Commons collections, Apache Commons Bean Utils, Groovy, Java runtime environment gadgets, Bean Shell, Jive, and Hibernate, Spring, and so on. So all the common libraries which you can find on the server side in the big application servers or in the applications which are running on application servers. In order to use Deserial, you just need to run it on the command line. You specify as a first parameter the gadget you want to create the serialized object stream for, and the command which you want to invoke is the second parameter, and that's it. And I've used a hex dump here. Whenever you see ACD, you know that it is a serialized object stream. Okay, that was a very short introduction into the Java deserialization problem and how you can exploit it. As I said, if you're interested, look at the presentations I mentioned in the very beginning. It's worth to read. Okay, now we will talk about the Java message service. The Java message is one of the core technologies in the Java world. As Oracle or Sun writes there, the JMS API is an API for accessing enterprise messaging systems from Java programs. The first version, which was adopted by vendors, was version 1.1. It was released in 2002. The newest version, a version which is released, is the version 2.0. And yeah, if you're interested, go on the Oracle web page and about 100 pages. Just some details about JMS. JMS is just an enterprise messaging technology. Some of us call it message-oriented middleware. It's included in the Java Platform Enterprise Edition since version 1.4, which is from 2003, I think so. And the latest version of Java EE, which is version 7, includes JMS 2.0. JMS defines an API for sending and receiving messages. It does not define how the messages are sent and received over the wire, over the network. It's just an API. You can use it for programming, and what is happening on the wire, you do not need to care. There's, as with all JMS core technologies, there's a reference implementation which is called Oracle OpenMQ. It's supporting JMS 1.1 and also JMS 2.0. And just to give you a short impression where JMS is supported. So first of all, we have the message brokers, which are, let's say, the data hub or message hub of JMS. And we have very well-known products like IBM WebSphere MQ. We have a appliance from IBM, which is called IBM Message Site. We have Oracle OpenMQ. We have PyWaddle / VMware RabbitMQ. We have a German company, which is IoT Software SwiftMQ. We have Red Hat HornetQ. We have Apache ActiveMQ. We have Apache Cupid, and so on. There are several other message brokers out there. We have J2EE application servers, because as I said, JEE application servers implement the JEE standard or specification, and JMS is included since version 1.4. They all need to implement JMS. So IBM WebSphere is supporting it. Oracle WebLogic is supporting it. Oracle Glassfish is supporting Red Hat. JBoss is supporting SAP NetWeaver. ACE Java is supporting it. Apache Geronimo and also Apache Tomii. And we have integration platforms. Architects usually call them ESBs. I call them integration platforms. And those products are usually built on top of JEE application servers. And there are very well-known products like IBM Integration Bus, IBM WebSphere ESB, Oracle Service Bus, Red Hat JBoss Fuse and ESB, MuleSoft Mule ESB, which is a cloud ESB, Apache Service Mix, and Apache Camel. So all of them are supporting JMS. You can send and receive messages using those products. And just to give you an impression where the software is used, so as I said, CodeWhite is doing a lot of red teaming. And what I've seen at our client environments is that especially in banks, insurance companies, telco companies, and also in military environments, JMS is used. From an architecture's point of view, JMS is very simple. In the middle, you have the JMS broker, and you have JMS clients. Can be 1, can be 100, can be thousands of JMS clients. All JMS clients create a connection to the broker. They initiate the connection. The JMS broker is just a standalone server. It provides all its JMS clients with connectivity and message storage and delivery. It can be implemented in any language. Can be Java, can be Erlang, can be C++. And it just maintains destinations, which are queues and topics. JMS clients are just Java applications. They can run on the server side or on the client side. They can have two roles. They can be a producer, which sends messages, and they can be a consumer, which just receives messages. And a Java program can also have both roles. It can send and receive messages. And they all have a connection to the broker using a specific protocol, which we will see later. And to support transaction management, something like XA transactions, JMS also supports the concept of sessions. A message broker hosts destinations. We have two types. The first one is the JMS queue, which is a one-to-one communication model. So a producer, which could be a Java program or a server-side program, just sends a message to a specific queue, and this message will be distributed to one consumer. So it's only a point-to-point communication model. The other one is the JMS topic, where a publisher sends one message to a broker, and the broker delivers all the messages to its subscribers. So it can be 100 Java programs, 100 WebSphere systems, or whatever. As I have already mentioned in the very beginning, JMS does not define which wire protocols need to be used. The wire protocol is just the protocol on a binary level, which is used for sending and receiving. And in the past, most of the JMS brokers had their own implementation of a protocol. And since several years, very well-known standard exists. For example, the AMQP, Advanced Message Queuing Protocol, which I think was initiated by JP Morgan. The MQTT, MQ telemetry transport, which is used in the field of IoT very often. There's one which is called STOMP, Streaming Text-Oriented Message Protocol, which you can also use, for example, using WebSockets and the browser, and OpenWire and WebSockets. And to give you an impression which products are supporting which protocol, most of them have their vendor-specific protocol, and the newer ones, or let's say the bigger ones, also support AMQP. Some of them support OpenWire, some of them support MQTT, and most of them support STOMP and also WebSockets. I marked some cells as red. They're very interesting for us because those protocols for the specific product can be used for sending and receiving messages using JMS. And that's the way I want to exploit target system. From a programmer's point of view, JMS is very simple. You need a couple of lines of codes. First of all, you need a connection factory. This class is always vendor specific, and the class name is also vendor specific. So in this case, I used ActiveMQ connection factory, which is from Apache ActiveMQ. And the connection factory usually hides all the connection and protocol details and IP address and hostname and port and stuff like that. When we have a factory, a connection factory, we can create a connection by calling the createConnection method. You can either use it without password and username, or you can use it with. It's up to you. It depends on the configuration of the broker. Afterwards, when we have a connection, we can create a session. And we can have transacted session and non-transacted session. In this case, I used a non-transacted session. So I used false. And all the messages will be auto-acknowledged. When we have a session, we can get a, let's say, handle to a queue which exists on the broker by using the createQueue method on the session. And in order to send a message to a queue, we need to create an instance of a message producer by calling the createProducer method on the session and pass the queue as a parameter. Then we start the connection, and then we create one of the messages which we want to send. In this case, I used a text message, and I just put a text, this is the payload, into the message and send it using the producer, and then close the connection. Very simple, a few lines of code. Receiving message is almost the same. In the very beginning, we need to create, again, a connection to the broker using the factory and the createConnection method. And we also need to create a queue. And instead of creating a message producer, we need to create a message consumer. In order to receive messages, then, we invoke the receive method on the consumer, and this method will block until the message is received. And then we can work on the message and, for example, check which type it is and do what we want with that. There's another way of receiving messages, which I call the EGB style. EGBs are server-side components defined in the JEE specification, specifically in the enterprise Java bean specification. There are 3 of them: session beans, entity beans, and message-driven beans. And this piece of code is running inside a JEE application server like WebLogic or WebSphere. And what I've created here is a message-driven bean, which implements the message listener interface. And this interface just defines one method, which is the on message. This piece of code is listening for a specific queue, which is called CW queue and is of type queue. And whenever a message is sent to this queue, the application server will invoke the onMessage method on this message-driven bean. JMS messages are pretty simple. They only have a header, properties, and a body. The headers are defined in the JMS specification. If you're interested, look at the class JavaX JMS message. There are a lot of getters and setters, and they are used for getting and setting the headers. For example, destination, delivery mode, return address, and stuff like that. Application programmers can also use or store properties inside a message. It's just a set of key value pairs of primitive types. And the most interesting thing about a message is the application data, which is in the body. JMS currently defines 5 message types. We have a bytes message, we have a text message, we have a map message, we have a stream message, and we have an object message, which sounds very great. And I just took the definition from the JMS 1.1 specification. So stream message is a message where the body just contains a stream of Java primitive values in a sequential order. A map message is just a message which contains a set of a set of key value pairs, and all of them are of primitive types. A text message just contains a string. A bytes message just contains an array of bytes. And the object message contains a serializable object. So whenever you read serializable in a specification of Oracle, you already know what that means. Boom. And if you look at the definition of the object message, this interface is very simple. It only has 2 methods. One to store a serializable object in a object message, which is called the setObject method, and you just use as a first argument the serializable object, and then it will be stored in the object message. And in order to get a serializable object again from the object message, you just invoke the getObject method, and as you can see from the return value, it is serializable. And this specific interface needs to be implemented by every JMS broker/vendor. So they all have their own implementation classes for object messages. And I mean, you already can guess what getObject is doing. I mean, it's serializing data. And this will bring us to the interesting part, which is attacking JMS. So the process of vulnerability discovery was pretty funny. So I just thought about, okay, what is running in the environment of our clients? And I thought, okay, yeah, they usually have some brokers running and JE application servers, so it might make sense to look at those products and find out if they are vulnerable or not. My guess was, okay, as with always, most of them might be vulnerable. So the priority was just based on what I have seen most in the client engagement, for example, IBM WebSphere and so on. I haven't looked at any integration platform at all because I knew that they are built on top an application server usually. And application servers usually reuse existing brokers. For example, Red Hat EAP. And so the latest version is using ActiveMQ Artemis, and the older versions are using HornetQ from Red Hat. IBM WebSphere application server is using IBM WebSphere MQ. Oracle Glassfish is using Oracle OpenMQ. And as a result, all object message implementations I looked at were deserializing from untrusted input without any validation. And just to give you a short impression what that means, I will show you a lot of advisories here. So the first advisory I sent out was to Apache ActiveMQ, and I was telling them, okay, you're deserializing from untrusted input by using a special library called Xstream and also object input stream. It was a bunch of lines of code where I showed them. It was in September last year. The next one which I sent out was to Red Hat regarding HornetQ, and I told them, okay, the implementation class of the object message deserializes in method getObject from untrusted input. No validation is applied. Same wording again for Oracle OpenMQ. The implementation class of object message deserializes from untrusted input in getObject. Sent out in March this year. Same wording for WebSphere MQ. I don't want to repeat it anymore because, maybe I should repeat it here. WebSphere MQ had two ways to trigger it. Not only the getObject, but also the getObject internal, which can be triggered by another method. Next one was Oracle WebLogic. The funny thing here is that not only the object message is vulnerable here, but also the text message and a special message type which is called XML message. So whenever you're using text messages or XML messages or object messages in your software and you read the body of the message in your application, you're vulnerable to a deserialization vulnerability. Next one was RabbitMQ, also in March. Same wording, the implementation class of object message deserializes from untrusted input in method getObject. No validation is applied. Then we have an appliance from IBM, same wording, also getObject, another implementation class. Then we have a German software company, it's called SwiftMQ. So the product is called SwiftMQ. Hopefully the software is not used in Swift environments. And same wording, the implementation class of object message deserializes from untrusted input in method getObject. Another one, ActiveMQ Artemis. It's funny because ActiveMQ Artemis is the successor of ActiveMQ and HornetQ. So they merged both projects together. So they are sharing some code, or I think most of the code is from ActiveMQ, and they incorporated the protocol of HornetQ. And ActiveMQ was patched very early, as you will see later on, but they did not incorporate the patch into ActiveMQ Artemis, which is funny. Another one is Apache Cupid. They have two brokers, one implemented in Java, the other one implemented in C++. Same problem, method getObject is vulnerable to deserialization of untrusted input. And I also have a cloud provider for you, which is Amazon SQS, Java messaging, and the same problem. So we have about 13 vulnerabilities. I would say it's only one bug, because it's from the specification, and all vendors implemented it without any validation. And just to give you an impression what is patched and what is not patched. So Apache ActiveMQ was patched pretty early, and they implemented white and blacklisting. So whenever you use this product, please use whitelisting. Red Hat Hornet Queue is not patched, Oracle OpenMQ is not patched, IBM WebSphere MQ is not patched, Oracle WebLogic is patched, but they implemented blacklisting, and the blacklist can easily be bypassed if you're interested. Look at my RuSec slides. I have shown there how you can bypass the blacklist very easily. IBM message site, Pivotal RabbitMQ is not patched, IBM message site is patched, but the patch looks like this. They just deactivated the use of object messages at all. So whenever you want to use object messages anymore, you need to use you need to set a specific system property, which is, in my opinion, not a patch. Apache ActiveMQ Artemis is not patched. Apache Cupid, so both versions are already patched, and they implemented the same strategy like Apache ActiveMQ. Exploitation of those vulnerabilities is fairly easy. You just take the same code which I have shown you in the very beginning for sending messages. And what you need to do is you need to create a connection factory, connection, a session, and a producer. And then you need to create an object message and put a serializable gadget into the object message. That's it. And then send it to the target system. And if the target system is receiving object messages and invoking the getObject method, it deserializes from untrusted input, and then hopefully we get calc. There are two exploitation scenarios. The first one is the queue exploitation, where we as an attacker send a message, an object message containing a serializable gadget. And this gadget is distributed using the broker to the target system. And the target is invoking the getObject. This one is boring. The topic exploitation is very interesting because we as an attacker send a message, it's sent to the broker, and the broker will deliver it to all of its subscribers, and it might happen that you get a lot of calcs. It really depends on which applications are listening on the topic, which, for example, an application server, a Java program, really depends on. I have seen systems for clients, maybe 20 systems listening on the same topic. So just send in a message and you get 20 calcs, hopefully. And the successful exploitation of the topic exploitation really depends on several factors. For example, which JRE version is running on the target system. If it is an old one, we can use JRE gadgets. It's a new one, it won't work. Which libraries are bundled with the application? Is there a commons collection, for example, in the application or not? Which libraries are in the class path of the runtime environment, for example, the application server? Can be Red Hat, JBoss, whatever. Does the runtime environment have or has separate class loaders, which have a separate resolution scope? For example, Red Hat JBoss has a very good architecture because they're using OSGI, and it's not very easy to exploit some of them. And it also depends on if the Java Security Manager is enabled. I haven't seen that very often in our engagements, 2 times. And one of the most important facts is JMS is asynchronous, which means you won't get any feedback. You just send the message to the queue or the topic, so just send it to the broker, and it will distribute it. And you won't get any stack trace. You won't get any reason why it's not working. And that was also the reason why I thought, okay, we need something like a black box assessment tool, which sends gadgets using object messages. And this will bring me to the next part of my presentation, which is the tool JMAT. JMAT is the Java message exploitation tool. It's a command line tool. It's open source. It's on GitHub. It's currently a private repository, but I will open it after the session is finished. It integrates Chris Frohoff's Viso serial to create gadgets. It currently supports 3 exploitation modes. The first one is the serialization exploitation mode or gadget exploitation mode. I also support attacks for XML parsers, XXE, and also a custom one, but it's not part of this presentation. JMAT can also be reconfigured and customized using JavaScript. And as I said, it's on GitHub. It's on my GitHub repository, and I will open it after the session. Currently, I'm supporting most of the JMS brokers out there, except Oracle WebLogic, Amazon SQS, and what is it, IBM Message Site. So IBM Message Site and Amazon SQS will follow soon. And I don't think that I will support Oracle WebLogic very soon, because in order to send messages over to Oracle WebLogic as a broker, a RMI protocol is used, which is called T3. You might have already heard of it, that it is vulnerable. And it would also make my tool vulnerable to deserialization attacks. So I don't want to have you guys hacked when you're running my tool. Using JMet is quite simple. You just download the jar file or compile it with Maven. And you run it like java-jar, path to the jar file. You specify the username, you specify the password, you specify the queue or topic, and the implementation which you want to use. In this case, I'm using Artemis, which is active in QArtemis. And if you want to use the gadget exploitation mode, so sending serialized gadget, you just use the -y parameter and specify the command which you want to invoke on the target system, and the target IP or hostname and the port, and that's it. And then you just run it. And if you can get a connection to the system, then it will look like this. And I also have a real-world example for you. As I said, I don't like to show tools on slides. Oh no, I think I have some stuff which I want to work first. So the target system, or finding a target system, took some time, because usually I think custom-built applications are using JMS. There are some applications out there, or some vendors out there, they have products which are using JMS. And I found one which is from HP, which is the HP Network Node Manager I. And HP Network Node Manager I is just a network management software. It's running on top of a JBoss 5, which is pretty old and ancient. And as I said already in the beginning, Hornet Q is used in JBoss. It supports local and LDAP authentication. So usually you integrate this piece of software with your Active Directory. And it makes heavy use of queuing and topics. And the process how I found the vulnerability was pretty easy. I just took all the jar files, I integrated it, I created a new Eclipse project, I integrated all the jar files into my project, I used the very well-known plugin which is called JD Eclipse, and I just looked for all classes which implement the message listen interface. And I found about 115 classes which are implementing this interface, which means we have about 150 message-driven beans, which is a lot. Most of them make use of text messages or object messages. One of the bad things is that HP Network Node Manager I requires authentication, or it's because of Hornet Q, because they usually require authentication. You really need to disable it. And another bad thing was that the permissions are pretty good set on all the queues and topics. So most of them can only be accessed by users which have the role system, most of them. But I found one, which is a topic. It's called the NMS Discovery Configuration Poll topic. And roles of type system and admin can send and receive messages to this topic. And the code which is receiving messages, so the subscriber is the class demand listener of package whatever, and it has an onMessage method. And what is happening inside the onMessage method is that first of, in the very beginning, there's a little bit of logging. Then they will cast the message to object message, and later on they will invoke the getObject method on the object message, which triggers the process of deserialization. And that's it. And just to give you the real-world example here, I have a VMware running, and you don't see it. Let's see if I can put it here. Yoo-hoo! It works, finally. Okay, now I need to type blind. Okay, so get it java-jar. So path to JMet. I created a user which is called admin. And I just used the simple password admin. And I used the implementation HornetQ. HornetQ. Oh, I cannot see it. Maybe I should go into full screen mode. HornetQ. And we want to invoke the command not xterm, calc.exe. And let me see. And the queue name, the topic name is nms.discovery configuration Paul, and the target IP is this one, 30, and destination port is 4457, and I just press the button, and as you can see, I've sent a lot of object messages to the target system. I sent gadgets like comments collection 1, comments collection 2, hibernate, JDK, and so on to the specific topic. And if we now go to the target system, which is here, we see, hopefully you guys can see the calcs, the system calcs. Let's do it bigger. So we have a lot of calcs here. The reason behind that is that, first of all, 3 gadgets are working in the target system. And the way, so you have seen there's a cast when the get object is invoked. And what will happen is a class cast exception will occur. So what the JMS broker will do is to re-deliver the same message again for 9 times. So 3 multiplied by 9 is 27. That's why we have 27 system calcs. Okay, so that was the real-world example, HP network node manage I. Now let's get back to the presentation. Okay, you have seen this. And now it's time for the conclusion. So as with several core technologies in the Java world, JMS suffers from the deserialization problem. All JMS providers I were looking at were vulnerable to deserialization of untrusted input. JMS topics and queues can be endpoints for exploitation in target environments, for example, in your client's corporate network. The exploitation of JMS highly depends on which gadgets are in the class path of the target system when serialization is used. And JMet is just a tool to make your life easier and to make exploitation easier. Okay. Thanks. So, thanks again for listening, and I'm very happy to answer questions.
You mentioned that JMS, the protocol, doesn't define the wire protocol.
Yeah.
Does any implementation could be vulnerable to SSRF or to a blind SSRF?
Could be, yeah. Could be. Yeah.
Any implementation in mind that could?
Not yet. No.
Okay. Thanks.
Welcome. Further questions?
Just a quick question regarding WebSphere MQ.
Yeah.
I see that all the time at some of our clients. What's been the vendor response for this vulnerability?
Could you please repeat it again?
The WebSphere MQ vendor response?
Sorry, I didn't get it.
Response from the vendor?
I have got a response from them that they received the message, but no fix yet. I think it's planned for Q3, quarter 3.
Thank you for the 0 days. Just a question.
It's 1 0 day.
You had one slide with a couple of CVEs.
Yeah.
Any idea? Did you take the time to look at how they fixed it? Like using black box versus white box?
So, I mean, I'm pretty sure that most of them will implement something like either deactivate it or implement whitelisting. But in my opinion, this is pretty tough because what it means is that all developers need to be aware of which classes can be sent and received over JMS using object messages. So you really have to define your domain model and find out, okay, what are the domain objects which I send around, and not more, not less. And if you think about an application service, usually you have a lot of applications running there, so it's not easy to find what you can whitelist and what you need to do. And that's why I think most of the software developers will not use any white or blacklisting at all, and that's why I'm also showed all the vulnerabilities here, because I'm pretty sure that this class will exist for many years, because nobody knows what is really used in its application, or for example in the application server you cannot whitelist it very easily. Right. And I'm pretty sure they just deactivate it, and that's why I also want to show to you guys that how you can exploit it, and that's also the reason why I released the tool, that it can be used in assessments and penetration tests.
Thank you.
Welcome.
Excuse me. Would you mind putting up the slide you had with all the ports listed?
Sure. Let me check. The ports, yeah. There you go. Oh no. Where is it? Okay. Okay, something is going wrong. Let me check. Uh-oh. Just a second. Now it should work again. Yeah. So let's get to the ports. The ports are, sorry, something is not working. Was it? No, there is, no, I'm too far, sorry. Where is it? Ah, there you go. Okay. Okay, yeah. This one? Okay.
I have a question.
Sure.
So for the ones without patches available,
Yeah.
could you advise people to try and remediate this through input validation on the server side? Or does the very fact that it's deserializing prevent you from doing input validation?
So first of all, you need the patched version, and then the vendor needs to have the possibility for you to specify a whitelist. Then it can be rendered. What you can also do is you can use a Java agent, which is called not so serial, and run it. But you really need to aware what is happening inside your application, because with not so serial you can block, for example, deserializations and stuff like that. So you can use it, but I wouldn't use it for an application server, for example, because you never know what is happening inside there.
Okay. Thank you.
Welcome.
For the ones that are currently not fixed, what is the time frame for them to fix it, or did they give you a reason why they haven't yet fixed it?
So from Amazon SQS, I heard that they will address it in future releases, so no time frame. I heard from a developer of Red Hat that they won't fix it because Red Hat is saying it's after authentication, it's post-authentication, so there's no need to fix it, which is, in my opinion, not a good reason. And from the others, from IBM, I heard they will fix it in quarter three, and from the others, I haven't heard anything. But to be honest, I haven't put any pressure of them because I have found about 20 deserialization vulnerability in the last year, and I'm not following all of them.
Thank you.
Welcome.
All right, we are out of time for questions. Thank you very much, Matthias.
Thanks a lot for listening. Thank you.